台湾以晶圆代工闻名全球，我手上拿的这片就是12寸的晶圆，它是半导体结晶的圆形切片。将其加工之后呢，就可以得到我们日常生活中所有电子用品都不可或缺的晶片。
The most crucial keyword in Taiwan is the semiconductor. But what exactly is a semiconductor? What does this high-tech chip have to do with soy milk? How did Taiwan get to this point? And where will it go in the future? Hello, I'm Zheng Guowei. I'm the founder of Pensai Science Media in Taiwan. In this episode of Taiwan Keywords, we will guide you through Taiwan's semiconductor industry. What is a semiconductor and what is a wafer? Before the show starts, I'm going to explain these technical terms. Semiconductor refers to silicon, germanium, arsenic. These are materials between conductors and insulators, the main material used to make wafers. A wafer is a slice of silicon made from a semiconductor, available in different sizes such as 8 and 12 inches in diameter. An integrated circuit is printed on the wafer. After processing and dicing, it becomes the chip. Because the process is very complicated and precise, thus a huge downstream industry trend is formed. The IC is an electronic circuit component on the wafer. Hundreds of millions of components are being concentrated on a small chip, forming an integrated circuit. The so-called 3nm and 2nm processes refers to the gate width of transistors. The smaller the number, the higher the density of transistors, and the more difficult the manufacturing technology. Taiwan has a key position in the semiconductor industry. In 2021, Taiwan's wafer foundry work accounted for 64% of the global revenue. As for the high-end semiconductor below 10nm, Taiwan accounted for 92% of the global production capacity.
台湾半导体产业的组成大概包括几个次产业，包括 IC 设计，然后晶圆代工、IDM 跟 IC 封装测试这几个领域。那我们如果以2021年的全球的市占率来看的话 ，IC 设计是拿下24% 的市占率，然后晶圆代工是67%，然后 IC 封测的话是58%。所以半导体要产制的过程中间，绝大多数就是由台湾的这种半导体产业所贡献的。
It is surprising that Taiwan's achievement mostly came from just one company, Taiwan Semiconductor Manufacturing Company, TSMC.
新冠疫情后，然后跟美中贸易战后，各国都发现说，就是这个半导体是属于这种国家安全跟供应链安全的重中之重。发现说，如果没有了台积电，我的汽车最先进的，譬如说 AI 的晶片，我就做不出来。
TSMC founder Morris Chang once proudly stated, "If it weren't for TSMC, the smartphone would not have appeared so early and changed the way of life of billions of people."
如果没有台积电的话，我们的科技发展进程有可能会延后的5到10年的发展。
台湾的半导体产业以及台积电在全球无可取代的地位是怎么开始的？这个故事要从这条街上的一家豆浆店说起。
In 1974, there was a soy milk store here. At that time, the political and financial leaders of Taiwan gathered and had a breakfast meeting. They based the technology framework on IC technology. In 1980, the first semiconductor company was established in Taiwan, now known as the United Microelectronics Corporation. UMC is still the giant of semiconductor industry worldwide. In 1987, Morris Chang, the then president of ITRI, founded TSMC with government support.
这里就是台积电的起点，工研院的电子与光电研究所。很难想象，这家35年前从这里起步的公司，在2022年的1月，已经跻身为市值6400亿美元的世界第10大公司。我是今天负责采访您的国威。
哦，你好。
对。 我们都知道工研院在台湾的半导体产业发展上扮演非常重要的角色哈，但具体来说是扮演什么样的角色呢？
这个可能就要回到快40年前，大概1974年左右，工研院基本上选训了一批学生，跟美国当时的 RCA， 就是一家半导体公司签订了合约，说派这群选训的种子，去就是 RCA 受训1年到1年半不等，然后回来之后，在工研院建立就是自己的一个示范工厂，把整个的基础打下来。1985年的时候，那就是工研院就聘请张忠谋先生，从国外回来当工研院院长。当初整个工研院在半导体从 RCA 回来的基础，那开始就是那种有一些 spin off， 就是等于是台积电、联电就从工研院等于是 spin off 出去，变成一个正式的一个半导体公司。这是整个台湾的半导体的一个发展的一个最基础的一个当初的一个过程，这样。
那我手上这个就是传说中的晶圆，
对，
圆圆的一片这样子。
我先简单介绍一下整个这个细的晶圆是怎么来的。细的晶圆其实是从就是那种其实从沙子或土，就是2氧化硒提炼出来的。那一开始可能要把2氧化硒把它融化掉，所以融在一个非常高温的熔炉，然后呢让它渐渐凝固。所以一开始凝固的时候，并不是长得这个样子哦，是一个圆形的一个晶棒，圆柱形的一个形状。然后你再去把它切成一片一片的晶圆，里面这个东西一开始不是这样的哦，一开始只是一个空白片。然后呢，你在上面做一些制程，制程包括做一些光照、蚀刻、摄影的东西。然后这边就会有一区一区，如果你仔细看，这边有一个方形，一个方形，这就是一个晶片，一个 chip， 就是里面这样一个正方形的东西。
Morris Chang founded TSMC. Not only established a company, he also proposed a new industry model, professional wafer foundry model.
台积电当初设立的时候，就是定位说我们不做设计，我们只做制造的这一部分，那就是专业的一个半导体代工。
Unlike companies such as Intel and Samsung, TSMC specializes in wafer fabrication model. In the past, in the semiconductor industry, mostly one company handles both IC design and manufacturing and testing. TSMC's most unique feature is its focus on midstream wafer fabrication. IC design companies no longer need to have their own fabs. They only need to focus on the product design and then leave the manufacturing to TSMC. This unique business model changed the entire ecosystem of the chip industry.
为什么台湾会演变成这样的模式，以及以台积电这样的模式延伸出去，它又怎么影响了台湾的整个半导体产业？
其实台湾的科技产业发展起来是在 PC 时代，那台湾那时候的台湾的企业都是属于中小企业。我们台湾的中小企业非常的厉害的地方，就是走这种就是 specialization 这种专业化的模式，所以这包括说上游的这种半导体产业以及下游的 PC 产业都是如此。所以有些人做 IC 设计，有些人做晶圆代工，有些人做 IC 封测。然后我们厉害的地方就是 IC 制造跟晶圆代工跟 IC 封测各自都拿下全球主要的市占率。
半导体是一个非常高深的工艺，它总共里面有1,100道不同的制程，每一道制程都要做到那种就是奈米等级的那种精细的程度。晶圆代工这件事情不是台积电最早，可是专业晶圆代工这是台积电最早提出来的。可是专业这件事情改变了后面所有的生态。
The top 3 foundries by market share in the first quarter of 2022 are TSMC 53.6%, Samsung 16.3%, and UMC 6.9%. Over 60% of the market share is held by Taiwanese manufacturers. In contrast, only 12% of the wafers are made in the US. In an effort to expand US domestic manufacturing capacity, the Biden administration passed the CHIPS and the Science Act in 2022, of which announced a $52 billion investment over 5 years.
This is infrastructure. So look, we need to build the infrastructure of today, not repair the one of yesterday.
At the same time, TSMC announced that it will invest more than $100 billion over 3 years to expand R&D and production. They expect to spend $40 billion in capital expenditures in 2022 alone.
台积电宣布他们要投资，好，在未来3年内投资超过1000亿美元，来扩大研发跟扩产哈。那这个金额其实非常的惊人哈。
对。那
台积电他们这3年1000亿美元的这样子预算的规划，大概是要用在哪些地方？然后这会造成什么样的影响？
台积电从这种就是大概16、14奈米后，大概就逐渐拉开了跟竞争对手的差距，所以可以预见，在这么具有规模的资本支出上头的话，那未来它的市占率就会持续扩大。
In fact, TSMC is known for investing in R&D at the right time, constantly challenging advanced technologies. For example, during the 2008 financial tsunami, when the global semiconductor industry was forced to cut spending, TSMC did the opposite, doubled its capital expenditure in 2010, significantly increased equipment investment and production line expansion. As a result, the company captured nearly 100% of the 28nm foundry market share. Investing heavily at critical times, TSMC, or Taiwan for that matter, found its place at the right time.
假设这个晶片原来设计是用就是10奈米的制造方式去做，就里面的一个线宽大概就是用10奈米的等级。我今天如果变成5奈米，其他条件都不变。如果其他条件都不变哦，整个这个东西就可以长宽各缩短1半。所以它的面积同样的功能就变成1/4的晶片。我1块晶圆就可以产生4倍的晶片出来。
了解，就是一个不断降低成本又提高效能，
对。
However, can Taiwan's brilliant achievements in the semiconductor industry continue? As the transistor process moves into 3nm, 1nm, and even smaller stages, will there be a physical bottleneck?
5奈米、3奈米、2奈米，未来已经到1奈米，1奈米下去怎么办？已经快到原子的等级了。
从我念博士班的时候，大家就在说半导体的极限快要到了，可能台积快要做不下去了。
1nm is 1 billionth of a meter. It's hard to imagine what that means. The diameter of a hydrogen atom is about 1/10 of a nanometer. This means that 1nm is only about 10 hydrogen atoms in size. TSMC's challenge is to make a super precise chip at the scale of an atom. Is it possible to keep on miniaturizing?
很多人讲说半导体或者摩尔定律已经到一个极限，其实不然。现在讲的3奈米，其实里面没有代表任何一个元件的尺寸是3奈米。摩尔定律还没到一个极限，基本上估计至少10年内都还不会到一个极限。
For the past several decades, the industry has generally followed the Moore's law. Nanotechnology process size shrinks to 0.7 times the original size for each, and the number of transistors per unit area doubles. 10nm, 7nm, 5nm, 3nm. The number of the transistors doubles as the process continues to shrink. But to pursue Moore's law, is process shrinkage the only way?
那现在碰到的最大的挑战是什么？一个很重要的一个挑战就是新的材料。
新的材料，比如说石墨烯嘛，它的这种就是速度可能可以更快这样子。砷化镓这种是用在射频用途的，就 RF 它做功率放大器的。功率半导体现在主要比较常看到的就是氮化镓，它也可以用在功率半导体上，然后再来就是碳化矽。以碳化矽来讲，就是可以至少做到矽的5到20倍的电流密度。
In addition to continuous process reduction, we can also use new forms of 3D processes or new materials that are more efficient to achieve higher chip efficiency to continue the growth of Moore's law. But these changes are also a challenge for complex advanced processes.
当然，新的材料加到 silicon 上面有一定的挑战，因为光换一个新的材料，我刚才讲，半导体的制造是非常精细的。你就想说，前后有几百道制成，你中间一道换一个新的材料，你前面的几百道跟后面的几百道可能都要重新改，所以这个是一个非常挑战的过程。可是工程师或者整个半导体业界一直在做这件事情。
The annual production value of chips worldwide was about 32 billion units in the 1980s. By 2020, it increased to 1,360 million units. Semiconductors have become the focus of international political and industrial attention.
半导体产业已经不再只是单纯的技术或经济问题，台积电甚至公开招募具有政治经济学背景的研究员，借由世界地缘政治的分析来协助他们做市场的调查。原本顺应国际分工趋势而崛起的台湾，该如何走出自己的下一步？未来台湾在半导体领域是否能继续独占鳌头？让我们拭目以待。